day, viewers. I welcome you all again to Dr. Ray class. There's a problem here I want us to solve together. Now, this is the question. The glancing angle of a beam of light incident on a surface is 20 degrees. First question A. What is the angle of incidence? Question B. Calculate the angle of reflection. C. What is the angle between the incident ray and the reflected ray? Question D. By how much will the incident beam be deviated? And lastly, E. What will happen to the glancing angle if What will happen to the glancing angle of incidence when the angle of incidence is increased? Now, when you look at it, it's as if they just gave one value, 20 degrees, and there are so many things to answer. Guys, I want you to know that this is one of the simplest questions you can handle on reflection. All you need to do is understand the little trick behind this kind of question, and you realize how simple it is. Now, I'm going to take us through the solution, and you will agree with me that this is one of the simplest things you can answer on reflection. Now, I've put up this diagram here. This diagram is going to help us see the situation of the glancing angle of incidence, the incident ray, reflected ray, and the reflecting surface. And with this diagram, we'll be able to answer all these questions very, very easy. Now, this is a reflecting surface, like a mirror. You remember what they call normal? That means on this surface, draw a line that will be perpendicular with this surface. Being perpendicular means it will make an angle of 90 degrees with the reflecting surface. That's what it means. So this is the normal. I've drawn this. Why is this normal very important? It's going to guide us in measuring all the other angles of interest. Now, this is the beam or light coming in on the surface. It is called the incident. The one that is coming in onto the surface is the incident beam. Now, remember, as a reflecting surface, the light cannot pass through. It's going to bounce off in this direction. This one that bounced off from the surface, going back from the same medium where it came, is the reflected ray or reflected beam. Guys, notice you measure angle of incidence as the angle between the normal and the reflected beam. Also, you want to measure the angle of reflection. It must be measured from the normal to the reflected beam. Now, the first question is, how do we get the value of angle of incidence? Now, you need to know the meaning of glancing angle. What does that mean? Very simple. You see the incident beam, right? There's an angle between the incident beam and the reflecting surface. That is called the glancing angle. So there's glancing angle of incidence. Also, there's another angle called glancing angle of reflection. That is the angle between the reflected beam and the surface. Now, what do I mean? Glancing angle is the angle between the incident beam and the reflecting surface. Or, glancing angle is the angle between the reflected beam and the reflecting surface. Very, very important. The angle between the incident beam and the reflecting surface, or the angle between the reflected beam and the reflecting surface. From the question, we are told that this G is 20 degrees. Can you see that? So, let's solve question A. If G, which is glancing angle, is 20, can you notice that angle of incidence and glancing angle is 90 degrees perpendicular? So you say that glancing angle plus angle of incidence So they are complementary. Glancing angle is 20 plus I equal to 90 degrees. Therefore, I is 90 minus 20. So angle of incidence is 70 degrees. See how simple that comes? So all you need to know is the meaning of a glancing angle. Now we've been able to calculate A, the angle of incidence. B said calculate the angle of reflection. Very easy. Do you remember that from the laws of reflection, angle of incidence is equal to angle of reflection. So this angle of incidence must always be equal to angle of reflection. That is the second law of reflection, right? So angle of reflection being equal to I is 70 degrees. It's as simple as that. There's not much we're going to do there. Just remembering those little information that are true. Question C says, what is the angle between the incident ray and the reflected ray? Now you ask, from this diagram, where is the incident ray? From here to here. Where is the reflected ray? This. What is the angle between them? Check between the two lines, the angle they formed. Okay. See how easy that comes. What angle is there between the incident ray and the reflected ray? It is I plus R. That means incident ray plus the reflected ray. 70 plus 70, 140 degrees. That is how simple that is. To calculate the angle between the incident ray and the reflected ray. Question D. This one may seem tricky, but it's one of the easiest, only if you understand where that is coming from. By how much will the incident beam be deviated? How do you understand this? Very simple. Look at this. Originally, look at incident beam coming down. It's supposed to continue going this way, right? It's supposed to continue going. But because of the reflecting surface, it bounced it back to this place. So, angle of deviation is actually the angle between where the light was supposed to go and where it eventually went to. So, where did it go to? This way. Where is it supposed to have gone? This way. So, what angle is from here to here? So, this is angle of deviation. Now, let me remove some of this so that the picture will be clearer for you to understand what I'm going to do next. You ask yourself, incident beam, you were going this way, right? You should have continued, but you couldn't. It went this way. Between where it's supposed to have gone and where it went, that angle from here to here is angle of deviation. How do we find it? You see that this line I'm tracing now is actually a straight line, and all angles on this straight line is supposed to be 180 degrees. What does that mean? Angle of incidence plus angle of reflection plus angle of deviation is equal to 180 degrees. Sum of angles on a straight line. So what is our angle of incidence? 70. What is our angle of reflection? 70. Plus our angle of deviation, we do not know, 180. So this is 140 plus angle of deviation equal to 180. Angle of deviation is 180 minus 140. This is 40 degrees, and that is the angle. This is how much the incident ray got deviated from its path.